Hello everyone, and in this video we're going to be solving linear equations. Usually this is the first thing you will learn in a algebra class, or maybe you will learn what a variable is first, but we're going to be solving linear equations. So linear equations are equations containing variables, which are usually x. They might be, other variables could be m, k, n, or other variables. But usually it's x when we're solving equations like this. And they're raised to the power of 1. We're going to get into other videos where x will be to the second power, which is pronounced x squared, or x to the third power, or fourth power. But when you just write x, this means x to the first power. And it might contain other numbers as well. So for example, x equals 2x plus 6 is a linear equation because it has x's to the first power and nothing else other than numbers. The square root of x to the fourth, or the square root of x equals 4 is not a linear equation because the square root of x equals x to the 1/2. And we're going to get into exponent laws in other videos, but note that this is not a linear equation because it's a different power other than 1. Now, when we solve linear equations, we want to solve for the variable, and it should be equal to a number. So x equals 1 is we call it solution. So your solution is kind of your answer, or it is your answer, but a solution refers to when a variable equals a number. So that would be, those are solutions. And when we look at the bottom example, x equals 3x plus 1 is not a solution because you still have x equaling something else with an x in it. So like this one, tell me about what number x is. That doesn't tell me anything about what it is. Now, to solve linear equations, I'm going to do some examples here. You need to get x by itself by eliminating other terms. And when we use the word term, we mean other things in the equation that are separated by plus and minus signs. So for example, 8 is a term, 5x is a term, 7 is a term, and 2x is a term. And you want to do the same thing to both sides of an equation. So for example, we're going to say, I'm just going to write off to the side here, 3 equals 3. Now that's going to seem really obvious, of course, but it's just, I want to demonstrate that doing both sides, the same thing to both sides of an equation, does still make the equation true. So, for example, if I subtracted 1 on both sides of that equation, I would get 2 equals 2. And of course that is true. 2 does equal 2. It's the same number. So if you do the same thing to both sides of an equation, equality holds. The two things will be equal. That doesn't mean that this new item will be equal to the previous item, but it means that the new equation, in the new equation, equality still holds. So now we're going to look at some examples of solving linear equations. So we want to get x equals something. With linear equations, now there's other methods to solve with when you have x to the power of 2 or 3 or other equations. But for linear equations, what you want to do is you need to get x equals something. And to do that, you want to eliminate as many terms as possible. So I notice here and I'll work this problem for you. If you subtract 7 on both sides, what you're going to get is 2x equals 5x plus 1. Now, equality still holds from here to here because I did the same thing to both sides of the equation. I subtracted 7 from both sides. So 7 minus 7 is 0. So we don't write the 0 traditionally. We're not going to write 2x plus 0. And then on the right side, we have 8 minus 7 is 1. Now we have 2x plus 5x equals, 2x equals 5x plus 1. Now, since we want x equals something, I'm going to get the x's on one side and the numbers on the other side. So you should have x's equaling a number. That's usually how you want to do it. You want to have x's on one side and a number on the other side. Or that's always how you want to do it, really. So, I'm going to subtract 5x on both sides. It doesn't matter what you're subtracting on both sides, as long as you do it to both sides of the equation. I could subtract a million, I could subtract a variable, I could subtract 1. It doesn't matter as long as I'm doing it to both sides. So negative 3x equals 1. Notice that 2 minus 5, that's just a pre-algebra calculation. 2 minus 5 is negative 3, and then we still have the x, and that equals 1. Now, right here, this is you multiplying by negative 3. To undo this, we need to divide by negative 3. That's another thing to keep in mind when solving linear equations. You want to do the opposite of what is being conducted. So, for example, here, we had plus 7. I want to do minus 7 just to undo it, because addition and subtraction are inverse, what we call inverse operations. They undo each other is the term we like to apply to that. And then multiplication and division are inverse operations of each other. And then when you solve other types of equations, more complex than linear, you're also going to learn other inverse operations. So we want to divide by negative 3 on both sides. So the negative 3 on the left and the negative 3 on the bottom, they go away. They undo each other. So x equals, that's a bad 3, x equals negative 1/3. And usually we like to write the negative on the top, on the top here. We really don't write x equals 1 over negative 3. So you always write the negative on the top. They are still equivalent, but that's just by tradition, I guess, that you put the negative on the top. So the next example is 2 times x plus 3 equals 7x plus 2. Now when you have parentheses around something, that means you multiply. That means you multiply the number in. So we have 2 times x plus 3. That means we have 2x. 2 times x is 2x plus 2 times 3 is 6 equals 7x plus 2. And then we solve like a normal, like the equation above. So I'm going to try to get the x's on one side, 7x minus 7x. So then that means we have 2x minus 7x is negative 5x. We didn't do anything with the 6. And then the negative 7 and positive 7x go away. So 2. And then we can subtract both sides by 6, get negative 5x equals negative 4. And then we divide both sides by negative 5 because we're undoing the multiplication of x. So x equals 4 over 5, and then that's the answer. So a negative divided by a negative is a positive, so that's why I was able to do 4 over 5 and not negative 4 over negative 5. So remember from pre-algebra that a negative times a negative is a positive times a positive is a positive, and negative times positive is a negative. And you'll get used to that once you solve so many. You're going to solve so many of these problems really in when you progress through geometry or algebra or other levels of math. You're going to solve all these problems all the time, and you're going to get so used to it. So now we have a third problem, but with fractions. So it's going to be the same process, however. So we're going to subtract 2 over 3x on both sides. These are inverses of each other. So that goes away. So and then we have 4 equals. Now 5/3 over 2 minus 2/3, that's 3/3, which is 1x. And then this brings up an important note. X equals 1x. So we don't write 1x really because it's implied that not writing a 1 in front of x means it's just x. Okay? So x is really the same thing as 1x, but we just don't write it like that. There's a lot of little like subtleties that you just don't write certain things. So I'm going to get rid of that 1. So x minus 10. And then if I add 10 to both sides, I'll get x equals a number. So x equals 14. So with linear equations, you really just want to have x equaling a number, and you want to manipulate the equation in a way that you're getting x's on one side of the equation, and then that'll equal a number. All right, and that's it for this video. If you have any questions, please leave them in the comments, and I'll be more than happy to address them.